Hello again and welcome back. Chapter 5, Lesson 5.2, Limits to Growth. Again, the goal for this chapter is to analyze how population size is determined by births, deaths, immigration, emigration, and limiting factors, biotic and abiotic, that determine carrying capacity. Look at the far side there. It says, hey, you stupid bovines, you'll never get that contraption off the ground. Think I'll run on hay? Say, maybe you'll make it to the moon. Nothing to do with what we're talking about except maybe the cows are emigrating off Earth. Maybe. Let's move on. All right. So our objectives are to identify the factors that determine carrying capacity, identify the limiting factors that depend on population density, and identify the limiting factors that do not depend on population density. I like this stuff. This is interesting stuff too. So think about it. What determines the carrying capacity of an environment for a particular species? In its native Asia, populations of Hydrilla increased in size until they reached a nice carrying capacity, and then the population growth stopped. But here in the United States, the Hydrilla grows out of control. So why does a species that is well behaved in one environment grow out of control in another one? Let's think about that. So first, objectives is to identify the factors that determine carrying capacity. So there are limiting factors. A limiting factor is a factor that controls the growth of a population. And there are several kinds of limiting factors, such as competition, predation, parasitism, and disease. Those limiting factors are what we call density dependent. They depend on population density. Others include natural disasters and unusual weather are not density dependent. They do not depend on population density for obvious reasons. So objective 1 is identify factors that determine carrying capacity. And an overall picture here, we'll look at more details obviously, is acting separately or together, limiting factors determine the carrying capacity of an environment for a species. And there are several different types of limiting factors that we just discussed, and we'll discuss more in length. Objective 2, identify the limiting factors that depend on population density. All right, density-dependent limiting factors operate strongly only when the population density, which of course is the number of organisms per unit area, reaches a certain level. These factors do not affect small, scattered population as much. Density-dependent, tightly packed, most likely, limiting factors include competition, predation, herbivory, parasitism, disease, and stress from overcrowding. Those little piggies would probably be stressed. Let's look at each one. Competition. When populations become crowded, individuals compete for food, water, space, sunlight, and other essentials. Some individuals obtain enough to survive and reproduce. Others may obtain just enough to live, but not enough to enable them to raise offspring. Still others may starve to death or die from lack of shelter. Competition can lower birth rates, increase death rates, or both. Competition is a density-dependent limiting factor. The more individuals live in an area, the sooner they will use up the available resources. Often, space and food are related to one another. Many grazing animals compete for territories in which to breed and raise their offspring. Individuals that do not succeed in establishing their own little territory, they find no mates and therefore cannot breed. For example, male wolves may fight each other for territory or access to the mates. Competition can also occur between members of different species that attempt to use similar or overlapping resources. This type of competition is a major force behind evolutionary change. The effects of predators on prey and the effects of herbivores on plants are two very important density-dependent population controls. This graph here shows the fluctuations of wolf and moose populations, wolves and moose, on the Isle Royale over the years. Sometimes the moose population, Isle Royale, grows large enough that moose become easy prey for the wolves. When the wolves have plenty to eat, what's going to happen? Their population grows. See? Moose, up goes the wolves too. As the wolf populations grow, they begin to kill more and more of those moose that are born. This causes the moose population death rate to drop. All right? So, I lost my spot here. As the moose population drops, again, the wolves begin to starve, and starvation raises the wolf's death rate and lowers the birth rate. So the wolf population starts to drop also. When only a few predators are left, the moose death rate then drops and the cycle repeats. That means that the birth rate increases. All right, herbivory can also contribute to changes in population numbers. From a plant's perspective, herbivores are predators. On parts of the Isle Royale, large, dense moose populations can eat so much balsa fir that the population of these favorite food plants drops. When this happens, moose may suffer from lack of food. In some situations, of course, humans' activities limits populations. For example, fishing fleets, by catching more and more fish every year, have raised the cod death rate so high that birth rates just can't keep up. And as a result, cod populations have been dropping. These populations can recover if we scale back fishing to lower the death rate sufficiently. Biologists are studying birth rates and the age structure of the cod population to determine how many fish can be taken without threatening the survival of this population. Parasitism and disease. Ugh. So parasites and disease-causing organisms feed at the expense of their host, weakening them and often causing death or disease. For example, ticks feeding on the blood of a hedgehog can transmit bacteria that causes disease. Parasitism and disease are density-dependent effects because the denser the host population, the more easily the parasites can spread from one to another. This graph down here shows a sudden and dramatic drop in the wolf population of the Isle Royale around 1980. At this time, a viral disease of wolves called canine parvovirus, CPV, was accidentally introduced to the island. This virus killed all but 13 of the wolves on the island, leaving only 3 of the survivors, luckily, were females. Okay, stress from overcrowding. Some species fight amongst themselves if overcrowded. Too much fighting can cause high levels of stress, which can weaken the body's ability to resist disease. In some species, stress from overcrowding can cause females to neglect, kill, or even eat their own offspring. Ugh. Stress from overcrowding can lower birth rates, raise the death rates, or both, and it can also increase rates of immigration. So objective 2 was to identify the limiting factors that depend on population density. Density-dependent limiting factors include competition, predation, herbivory, parasitism, disease, and stress from overcrowding. Objective 3, identify the limiting factors that do not depend on population density. All right, these are called density-independent limiting factors. These factors affect all populations in similar ways, regardless of the population size and density. Unusual weather, such as hurricane, droughts, or floods, and natural disasters, such as wildfires, can act as density-independent limiting factors. A severe drought, for example, can kill off great numbers of fish in a river. In response to such factors, a population may crash. And after the crash, a population may build up again quickly, or it may stay low for some time. Sometimes the effects of so-called density-independent factors can actually vary with population density. It is sometimes difficult to say the limiting factor acts only in density-independent way. So on the Isle Royale, for example, the moose population grew exponentially for a time after the wolf population crashed. Look at the moose. Then, A bitterly cold winter with very heavy snowfall covered the plants that moose feed on, making it difficult for the moose to move around to find food. Because this was an island, emigration was not possible. They couldn't leave. Moose weakened and many of them died. In this case, the effects of bad weather on the large, dense population were greater than they would have been on the small population. In a smaller population, the moose would have had more food available because there would have been less competition. All right, go back to our hydrilla story. In Asia, the hydrilla's natural environment, density-dependent population limiting factors kept it under control. Perhaps there was plant-eating insects or fish devour, or perhaps pest or disease weaken it. Those limiting factors, for some reason, are not found in the United States, and the result is runaway population growth. Efforts at artificial density-independent control measures, such as herbicides and mechanical removal, offer only a temporary solutions and are expensive. Researchers have spent decades looking for natural predators and pests of hydrilla. The best means of control so far seems to be an imported fish called grass carp, which views hydrilla as an especially tasty treat. Grass carp are not native to the United States, so only sterilized grass carp, which means they cannot reproduce, can be used to control hydrilla. I think you can understand why. All right, objective 3 was to identify the limiting factors that do not depend on population density. So they are unusual weather such as hurricanes, droughts, or floods, and natural disasters such as wildfires. They act as density-independent limiting factors. Let's review our objectives. Ask yourself, can you? Identify factors that determine carrying capacity. Identify the limiting factors that depend on population density. And finally, identify the limiting factors that do not depend on population density. And there's your cute picture. Adios.